Good morning. Today we are going to see the Coulomb's law. In your plus two classes, you have already studied in Coulomb's law, force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Today, now we are going to see the Coulomb's law in vector form. Okay, Coulomb's law in vector form. For that, we have two charges Q1 and Q2. Q1 is at a distance r from the origin, r1 from the origin. Q2 is at a distance r2 from the origin O. So we know the position vector of Q1 is r1 and the position vector of Q2 is vector r2. And r12 is the distance between Q1 and Q2. R12 is the distance between Q1 and Q2. R12. That is R12 equal to vector R12 equal to R2 position vector R2 minus position vector R1. Okay. So this R12 is equal to R2 minus R1 and the magnitude of R12, which we can take it as capital R. That is magnitude of R2 minus R1. Okay. Then we know a unit vector AR12 can be expressed as R12 divided by magnitude of R1. Okay. So now from Coulomb's law, we can find the force on Q2, force on the charge Q2 due to the charge Q1. We can express that as F12, which is equal to 1 by 4 pi epsilon 0, that is the constant we are using, into Q1, Q2 divided by the magnitude of the distance between Q1 and Q2 is R. That is R square into the direction is AR12. Okay. So we can rewrite this as 1 by 4 pi epsilon 0 Q1 Q2 divided by R is the magnitude of R12, that is equal to magnitude of R2 minus R1 square. AR12, we know AR12 is R12 vector divided by magnitude of R12. Okay. So which can be rewritten as 1 by 4 pi epsilon 0 Q1 Q2 divided by R2 minus R1 the whole square into R12 is vector R2 minus vector R1 divided by magnitude of R12. We know here from this magnitude of R12 is again magnitude of R2 minus R1. So it can be written as 1 by 4 pi epsilon 0 Q1 Q2 divided by this square into this one, that will be cube. Magnitude of R2 minus R1 the cube into R2 minus R1. This is the expression for Coulomb's law in vector form. That is a force on Q2 due to Q1. Okay, thank you.